Ever tried to code with just your voice? Or untangled a permutation puzzle that needs perfect balance? Today we dive into both, kicking off a new voice control project and tackling a tricky LeetCode challenge. This is day 42 of coding every day until I hit 1K subs. Today was a mix of new project development with a focus on voice interaction and a challenging combinatorics problem on LeetCode. Let's get into it. Kicked off a new project today called ClientX Voice. The idea is to create a bridge that allows the VS Code extension to interact with large language models using voice commands and get text-to-speech feedback. This first step was just getting the basic file structure and a placeholder main script going. After the initial files, I started fleshing out the README. This first part covers the high-level goal, making client work with LLMs through a local server, complete with voice feedback. The key features are an OpenAI-compatible API, TTS for important events, and browser automation. Next up in the README, what you need to get it running. Standard stuff like Python and OS Windows is preferred for some specific libraries, a browser, and of course, the necessary Python packages. Then, the usual clone and pip install commands. The README then details configuration, setting up image paths for GUI automation, adjusting request intervals, and optional TTS settings. For usage, it's about starting the Python server and then pointing client in VS Code to the local endpoint. The image directory is for PyAutoGUI if it's used for browser interactions. Diving into the technical side, the README mentions the API endpoints, the main components like the Flask server for handling requests, the TTS module for voice output, and the part that actually talks to the LLM. It also touches on rate limiting to play nice with web services. Finally, the RE8DME includes important limitations, especially around OS compatibility if GUI automation is heavily used, and the usual sections for contributing, license, MIT in this case, and a disclaimer. Standard practice for open source projects. After getting the initial structure and README in place for ClientX Voice, I spent a good chunk of time on the core experience, the text-to-speech and console interactions. There were several updates focused on fixing TTS bugs, making the voice feedback more targeted, like removing announcements, and generally improving how the console reports what's happening. It's an iterative process, getting that audio and visual feedback just right for a smooth voice-driven workflow. Still more to do, but it's definitely making good progress. Alright, switching gears from project work to a LeetCode problem. This one is count number of balanced permutations. Spoiler alert, it's a one involving permutations and a specific balance condition. The goal is to find how many distinct rearrangements of a given string of digits result in the sum of digits at even indices being equal to the sum of digits at odd indices. No H1 header as the code block is large. So here's the solution. This solution employs dynamic programming, specifically a digit DP-like approach, with memoization, at cache, to count balanced permutations. It iterates through each distinct digit type, 0 through 9. For each digit type, it decides how many instances of that digit are placed at odd indices, and how many at even indices. The DP state, digit_val, current_odd_sum, odd_slots_to_fill, tracks the current digit value being considered, the sum accumulated by digits placed at odd indices so far, and the number of odd indexed positions still needing to be filled by subsequent digits. Combinatorics, math.comb, are used to calculate the number of ways to choose positions for the current digit type among the available odd and corresponding even slots. The base case is reached when all digit types have been processed. A valid permutation is found if the current_odd_sum equals the target sum, half the total sum of all digits, and all designated odd indices have been filled. Pruning, using PSUM, prefix sums of digit counts, helps optimize by avoiding branches where remaining digits are insufficient for the slots that need to be filled. The time complexity is related to the number of DP states multiplied by the transitions, with space complexity for the memoization table.